Good morning, dear children. So today we are going to discuss about chapter sound for NTSC. In this lecture, I'm going to just give the quick recapitulation for the sound chapter, and I will try my best to explain the terms related to this chapter. Okay, so we are going to start this. The sound chapter, as due to pandemic, that was deducted from the syllabus by NCERT. So this is must. We should do that chapter, that is sound. So first of all, we must understand that what is sound. Before that, you must have a knowledge about that term that is called wave. So what is wave actually? So if you remember, when we throw a stone in the still water, then the stone will disturb the particles of the water, right? And the particles of the water will start vibrating. They will disturbing the neighboring particles. Then what happens? The neighboring particles will then start vibrating and further disturb the particles next to them. Suppose if I throw a stone here at that point, then the disturbance will be generated and it will pass to the next. It will move on. This disturbance in water is called a wave. So wave is what? It is a phenomenon of movement of disturbance in a medium, which is due to vibration. Okay, so this is the movement of disturbance. Movement of disturbance. And the reason behind that, the particles are vibrating. Right? Now, in that case, you might have seen this kind of curves are generated when we throw water in the throw stone in the still water, right? Up and down about their mean position. So when a wave travels from one point to another, then energy is transferred and the particles vibrate at their mean position. What I mean, if you keep a piece of paper here, that MCQ will definitely going to come in the NTSC exam. Please listen me very carefully. Suppose I keep a piece of paper here at that second point, right? And still I have not thrown a stone. The moment I will throw the stone in the water, the disturbance will be generated due to vibration. But that vibration will transfer only. The matter or the particles will not get transferred. What I mean, that paper will remain here. The disturbance will be generated. It will pass on, but the paper will remain at the same position. That means it will not move like that ke paper bhi iske saath move karega aage. That is not possible. So what the type of question will be there during the wave? What transferred during the wave movement of a wave? Energy, right? Matter and energy, only matter, both, none of these, like this. So please keep in mind only the energy transfer during the wave motion, right? Nothing else get transferred. That is very, very important. Okay. Now, next we can say about the propagation of wave. Some terms you must be aware about this. Propagation of wave means movement. ये word आपको बार बार सुनाई देगा इस chapter में. Propagation of wave, right? Propagation of wave simply means the motion of wave from one point to another. One very important, without which nothing can be possible. Movement नहीं हो सकती किसी चीज की. There is a medium. So medium is what? It is a matter or a substance through which a wave propagate. ये wave को propagate होने के लिए कुछ ना कुछ substance की medium की जरूरत होती है. That is a medium, right? Now, on the basis of types of vibration, कि किस तरह की vibrations होंगी उसमें, waves में. On the basis of this, we can classify the waves into two types. One is transverse and another is longitudinal. In this chapter, we are going to do this only. two waves, transverse and longitudinal wave. Now the question arises, what is transverse wave, what is longitudinal wave, right? So now that we are going to discuss one by one. So first of all, the transverse wave, very important, transverse waves. Transverse waves क्या होती हैं? In which the particles of the medium vibrate perpendicular. Perpendicular, how it is perpendicular? Suppose here is a tree, right? Here is a tree, and here is a boy standing there, right? And what is, he has just tied the rope here, right? Ending the rope with hand. In the next phase, what he do? He just gave a jerk to that. So what will happen when he will give a jerk? So earlier the position of the rope was with a dotted line. When he gave a jerk, then this kind of wave will be generated. If you remember that experience, you can also check with the rope. That is a rope. Rope with jerk, right? And this is rope only without jerk. There is no jerk, right? Now you can see the wave in which the particles, you can see the motion of the particles is perpendicular. Right? Motion of the particle is perpendicular. To which perpendicular? To the direction of wave. You can see wave is going this side and the particles are perpendicular to the direction of propagation of wave. So transverse wave क्या हुई? In which the particles of medium, right, vibrate perpendicular. Vibrate perpendicular to the direction of propagation of wave. To the direction of propagation. तो जिस तरफ वेव मूव करेगी उस डायरेक्शन में particles की जो वाइब्रेशन होगी that will be perpendicular. That is the meaning of transverse wave, right? Stress string, rope, इनके अंदर कुछ भी आप मूव करवाओगे तो वो ट्रांसवर्स वेव ही होती हैं उसमें. Okay, now some terms related to this. As you can see, this kind of wave will be generated. So now the distance between these 2 points, distance between the 2 waves, we can say, right? That is called wavelength, length of one wave. Okay, यहाँ से लेके यहाँ तक एक वेव होती है, तो सेंटर टू सेंटर ले लिए तो भी एक ही कवर होगी इसमें. There is no issue. And this point is known as amplitude, maximum displacement or maximum disturbance created, right? Now these hills and valleys, that is called a crest, upper region, and that is called a trough. Crest and trough. So these are the terms related to transverse wave. Now I would like to explain the crest and trough. Crest के अंदर क्या होता है? It is temporarily above the line of zero disturbance. This is called the line of zero disturbance. यहाँ पे कोई भी disturbance नहीं है, right? Now it is the maximum. Another point होगा जो trough होगा वो maximum negative displacement होगी इसमें particle की, क्योंकि body zero disturbance के नीचे, right? So this we have to keep in mind. Very important, right? Okay. Now next we have longitudinal. What about longitudinal? Let's see. The longitudinal waves कौन सी होती हैं? Longitudinal waves. Transverse wave we have already discussed. लॉन्गिट्यूडनल वेव के लिए क्या होता है बेटा, पार्टिकल्स ऑफ मीडियम वाइब्रेट पैरेलल एंड एंटी पैरेलल. What I mean by parallel and anti parallel, you will understand. Suppose this is a rigid sport, right, with which I tied a spring. Right? Now the spring is at rest. Now, what will happen if I will just compress or stretch that string? The vibrations will be generated like this. What I mean by this, we will see that when we stretch it or compress it, then there will be some regions generated, some different portions will be there. At some places the spring ki jo points and that will be farther apart than its normal position. You can see, as I can see here, these three, right, and where they are very far from each other. Earlier they were not at that point that much far. This region is known as rarefaction. Rarefaction. And there is another reason where they are very close to each other, like this, right? That is called compression. Compression, rarefaction. So compression is a region of high density, high pressure. Rarefaction is a region of low density, low pressure, right? So keep in mind, in compression region, density will be more. In rarefaction region, density will be less as compared to compression, right? Longitudinal wave को हम क्या कर सकते हैं? On the basis of compression has maximum density and rarefaction has minimum density. Now, basically, we have two types of waves: mechanical and electromagnetic. तो electromagnetic waves और mechanicals में क्या difference है बेटा? Mechanical wave, they need a medium for their propagation, right? And they do not require any medium. Mechanical waves जो होती हैं, they may be transversal and longitudinal, right? They light waves ये जो होती हैं हमेशा transverse in nature होती हैं, only transverse, longitudinal nature नहीं होती electromagnetic waves, right? So this is all about the introduction for the chapter के क्या-क्या terms हैं, क्या-क्या इसमें waves हम discuss करेंगे. Okay. Now the next is propagation of sound. How the sound propagate. When somebody speaks, you are able to hear. Now you are able to hear because of the microphone, right? That is another phenomena related to physics. Magnetic properties are in. But if you are sitting in front of me during the offline class, right, and I am teaching on the board, so then you are able to hear me. So how you are able to hear me? This you might have done in class 8 also, right? If there is a source of sound, right, and here is listener. When the source of sound will speak, we know that I am naming the particle. There are a number of particles. I am just numbering the particles 1 to 8, right? When the person will speak, then the vibrations will be generated. Obviously, wave आएगी, disturbance होगी, disturbance से vibrations से disturbance होती है. So that disturbance will strike with the first particle. Then what happen? First particle will come in motion and it will strike with the second particle. Then after striking the second particle, first particle will come back to its position back, right? This is elastic in nature. Elastic means that they regain their original shape or positions, whatever, wherever they were. So this disturbance will keep on moving until and unless the sound will not reach to the listener. This is the way that how the sound propagate, right? And we usually say that sound cannot propagate through vacuum. Why it cannot propagate through vacuum? We know that because in vacuum, these particles will not be there. right? These particles will not be there in vacuum. So that's why particles नहीं होंगे तो sound कैसे travel करेगा? That will be difficult for sound. That's why we say sound cannot travel through vacuum. Okay. Now the next is about characteristics, important characteristics. Characteristics of sound. Let's see what are the characteristics of sound. I would like to first name those. One is wavelength, right? It is denoted by lambda. It is called lambda. Then we have amplitude. That is denoted by A. Third is time period. That is denoted by T, right? Fourth is frequency. That is denoted by mu. And fifth, we will use the speed of sound wave. Speed of sound wave. Okay. Now let's discuss these one by one. To explain all these terms, I would like to draw a diagram with which it will be easy for me to explain all the terms. Zero disturbance. This is a zero disturbance line. Now the waves generated. Drawing the wave. Let it be like this. Okay. Now I'm going to write one by one the different terms which we have used here, like these 2 points, right? This is the maximum disturbance. You can see maximum disturbance. So this is called amplitude. जितना maximum वो peak तक जा सकती है, maximum value. That is the amplitude. Now the distance between these two, this I had already mentioned, that is wavelength, length of a wave, right? Length of a wave. That is denoted by lambda. And from this point to this point, that is called one wave, we can say. And time period is the time taken for a wave to complete one oscillation or one wave. And frequency is the number of waves per unit time, right? Or for a number of complete waves produced in 1 second, right? So how we can distinguish between two sounds of different frequency? This is one sound. This is another. So what I can say, this is sound of high frequency, this is sound of low frequency. क्योंकि कम टाइम में ज्यादा वेव जनरेट करी हैं और इसमें ज्यादा टाइम में या सेम टाइम में कम वेव जनरेट करी हैं. So that will be having low frequency, right? And there is a relation between frequency and time period. Frequency is equal to 1 upon time period, that we all know. Unit of frequency we will use hertz, and unit of time period we will use second, right? Unit of time period will be second. Right. So now we are going to discuss the terms or the characteristics of sound, right? Three fundamental characteristics, very important. These are the fundamental characteristics of sound. Fundamental characteristics of sound. First is loudness. We are very familiar with that fundamental characteristic, loudness. As you normally, teacher always speak in the class, don't make a noise, right? So this is a loudness, that is a characteristic of sound by which a loud sound can be distinguished from a soft sound. Loud sound को हम soft sound से compare कर सकते हैं. But how? How we will come to know? Because it depends on amplitude. Amplitude के ऊपर depend करता है. What I mean, like if I draw this way, one is this, right? And another is this. Now you can see amplitude. Iska high hai, iska low hai. This is soft sound, right? And this is loud. So this way we can distinguish between these with the help of amplitude, right? Now you have to learn these points, which I'm going to explain now, that the factors on which it depends. Question aayega, which of the following factor, name the factor on which loudness does not depend. 4 options will be there because mainly 3 factors hain hamare paas जिस पे loudness depend करती है. First, it is directly proportional to amplitude. Directly proportional to amplitude. जितना ज़्यादा amplitude, उतनी ज़्यादा loudness. Second, inversely proportional to distance. कौन सा distance? Distance between listener and source. राइट कि जो पर्सन साउंड प्रोड्यूस कर रहा है और जो सुनने वाला है उनमें डिस्टेंस ज्यादा होगा तो लाउडनेस कम होगी, राइट. थर्ड इज इट डिपेंड्स डायरेक्टली ऑन द डेंसिटी ऑफ द मीडियम, डायरेक्टली प्रोपोर्शनल टू डेंसिटी ऑफ मीडियम, राइट, थ्रू विच साउंड प्रोपेगेट्स. तो लाउडनेस जो होगी वो सॉलिड में मैक्सिमम होगी और जो लिक्विड है और गैसेस है उसमें मिनिमम होगी, सबसे कम होगी, राइट. और लाउडनेस का जो मेजर करने का एक यूनिट भी होता है बेटा, कीप इन माइंड दैट वी कॉल डेसिबल्स, डिनोटेड बाय दिस स्मॉल डी कैपिटल बी, डेसिबल्स. ओके, राइट. नाउ द सेकंड वन इज pitch. Pitch. What is pitch? Pitch is a shrillness of sound. Male female की जो वॉइस है वो हम pitch से ही आइडेंटिफाई करते हैं, राइट. चाहे दोनों की सेम लाउडनेस है, मेल की जो वॉइस होती है दैट इज फ्लैट एंड फीमेल वॉइस इज श्रिल. So it is the pitch of sound by which we can distinguish between the voice of boy and a girl. Very important question. Okay, which of the following characteristics is used to distinguish between the sound of a boy and girl? Loudness, pitch, or other 2 options will be given. So pitch. But on which factor it depends? It depends on frequency. It depends upon frequency. What I mean by this, जितनी ज़्यादा frequency, उतनी ज़्यादा pitch. One sound is this, right? I'm just increasing this line. 0 disturbance. Now I'm C. Now children, I told you that frequency is number of vibrations per second. Now see, the time is same. In both waves time is same. यहाँ पे कितनी waves generate हुई? 1, 2 and 2.5, right? और यहाँ पे 1, 2, 3, 4, 5, 5.5. टाइम सेम है, तो इसका मतलब ये जो साउंड है इसकी जो पिच होगी वो हाई होगी. Why? Because of high frequency and it will be of low pitch. This is the meaning of high pitch and low pitch. It depends upon frequency. Right? Okay. Now the third one is quality, or what we call timbre. Quality or timbre. What is the meaning of quality or timbre? Now suppose the sound is having the same loudness, right? Helps to distinguish between sound of same loudness and pitch. मगर loudness भी same है, pitch भी same है, so we can identify with the help of quality or timbre. Like in a dark room, right? We can identify our friends with their voice only. That characteristic is known as quality. Right? Okay. Then we have speed of sound. जो स्पीड होती है साउंड की डिफरेंट मीडिया के अंदर, obviously it won't be same in all the mediums, like solid, liquid and gases. It will be different for different reasons, right? It is a rate of transfer of disturbance from one point to another. Solid में जो particles हैं, they are very close to each other, तो सबसे ज्यादा solids में होगी, right? और liquid में थोड़ी कम होगी than in solid, and speed of gases के अंदर बिल्कुल least होगी. That you have to keep in mind. And generally जो हम speed of sound air में use करेंगे, because in numericals we are going to use this speed of sound in air, that will be 346 meter per second, right? Approximate. And very important, at 25 degree Celsius. 25 degree Celsius भी याद रखना है, right? Because speed of sound depends upon temperature. टेम्परेचर के ऊपर डिपेंड करता है, राइट? स्पीड ऑफ साउंड इंक्रीज करती है विद इंक्रीज इन टेम्परेचर, इंक्रीजेस विद increase in temperature. That is why, children, I have mentioned here 25 degrees Celsius. Right? 25 degree Celsius. That is why I have mentioned here. Okay. Now, very important, sonic boom. ये आपको सिर्फ टर्म को याद रखना है आपको, sonic boom. Whenever something moves greater than the speed of sound, greater than speed of sound, that is 346 मीटर पर सेकेंड, तब हम बोल सकते हैं कि बॉडी इज मूविंग इन सुपरसोनिक साउंड. जितने भी जेट एयरप्लेन्स हैं, रॉकेट्स हैं, फायर बुलेट्स हैं, दे ऑल मूव विद सुपरसोनिक साउंड, राइट? व्हेन अ बॉडी सेज अ बुलेट, इट मूव्स विद अ सुपरसोनिक साउंड. शॉक वेव्स आर प्रोड्यूस्ड इन एयर. जो ये शॉक वेव्स होती हैं, दे कैरी लार्ज अमाउंट ऑफ एनर्जी एंड प्रोड्यूस अ वेरी शार्प एंड लाउड साउंड, जिसको हम बोलते हैं सोनिक बूम, राइट? So it is produced by the aircraft also at low altitude, can shelter the glass. अगर जो aircraft है थोड़ा low altitude पे जाएगा तो window panes होते हैं, that will produce sound and it may shatter the glass and windows also, right? It may cause headache and can even damage the tissue in the inner ear. अगर हम continuously उसको सुनते रहें, then it will be very effective for us. Okay. So that is all for today. half of the chapter almost we have done, and the remaining part we are going to do in the next class. Thank you so much.